Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Berk, and I do data engineering and machine learning at Databricks. I'm joined by my co-host,
Ben Wilson. I evaluate agent frameworks at Databricks.
Can you elaborate, Ben?
That's just what I'm doing this week.
Okay, cool.
Part of the work this week is looking at what people are using and what are potential cool things for MLflow to integrate with.
Awesome. Cool. Well, today we are speaking with Abi. She studied mathematics in university, both at the undergraduate and at the master's level, and she worked in a variety of ML and software roles after graduating. Currently, she's writing a book called LLM Ops, Managing Large Language Models in Production, and also is working at Abide AI, an ML services org that she founded. So, Abi, I was going to tee you up with a question, but I'm completely going to go off the rails. You worked at UCLA as a researcher under the legendary Judea Pearl, and you were trying to do emotion recognition in the speech and video space. And if listeners are not familiar, Judea Pearl is a legend. He won the Turing Award, and he worked in probabilistic and causal, quote-unquote, ML, what has become ML over these years. So why did you choose this application to research?
So I didn't choose it. I was assigned to work on, basically what he told me to work on was how you define what autonomous agents are. So that was the thesis. And I spent a couple of months, which is I looked at things from like a causality angle, and there are two kinds of causality. There's one causality, what Julia studies. And then there's Joseph Halpern, he studies causality as well, and we both have different flavors of causality. So I looked at all of their research. I looked at the research in philosophy. I looked at more research in economics, then in computer science. Eventually, I realized, well, I don't think I can sort of define autonomous agents the way I'm going about this. So I said, well, if I can't define it, let me try to break it down into three things. For any agent to be autonomous, it has to be able to do a few things. First is it needs to be able to pick its own algorithm, which is it needs to know based on the task itself what kind of machine learning model does it need to use. So that, to me, falls in the category of AutoML. The second thing it needs to do is it needs to be able to recognize emotions, to be able to switch context within a certain conversation as well. So that led me to work in emotion recognition. And the third part was multi-agent systems, which is how do different agents interact with each other within like an environment. So I researched independently in all three areas, which is I worked in AutoML, I've worked in emotion recognition, and in multi-agent systems for those 2 years.
All right, 50 questions coming right now. First, in the algorithm selection process, does that include the loss function?
Yes.
Whoa. Okay. That's blowing my mind. Because I one of the things that I always thought was super fascinating about agents as a concept is they have their own prerogative of what is success. It's not just a fixed definition. And so, it's a very interesting paradigm. Okay, I'll pause the 50 questions. Actually, what was it like working with Judea Pearl?
There's one usual thing which is said. Most of the professors in academia, they're sink or swim kind of person. Either they'll throw you at the problem and let you sink, or they will teach you how to swim. Julia is one of those persons who just gives you the topic, and maybe because he's a little bit senior as well. And I was asking him this question, which is, I especially went to him because I wanted to win a Turing Award. And I was like, well, you need to teach me how to win a Turing Award. And he was like, Abby, I've worked on the problem that I've worked on for 20 years. Every single day I've thought about that problem itself. And then one day you're making incremental research. And then one day you realize, okay, I think I have a solid framework which sort of works. And to me, it was more like nobody can teach you how to make incremental progress at something. You just have to have your own intuition on A, how to identify the right problems, B, just because there are a lot of people saying reinforcement learning is the right way to be able to do AutoML, that doesn't mean that it's the right algorithm or the right learning system to be able to do AutoML either. All of that comes from experience. So for me, it was more like one of those professors who just threw me at the problem, and then I would meet with him every 2 or 3 weeks. And I explained to him everything that I've read, my thoughts about problems. And he just sat there pretty much like a therapist listening to me. He took notes, didn't say anything. And that was pretty much the entire collaboration, which is, he was more like an emotional support system that was there, more than like, okay, do this, work on this. I think this is right or this is wrong. He never said this is wrong. More so because I don't think he had the expertise. And he's one person who doesn't disqualify an idea too quickly. Maybe, although that's sort of his personality on social media, that was around the time when the book of Why was announced. A lot of people were sort of vocal about how deep learning models do not have a model of causality, so they're not supposed to be good models of intelligence. But I think that has been, to some extent, disproven by now, which is they can become really good models of intelligence. Yes, they have their own limitations. So his social media personality is, I think, a little bit more out loud dismissing things, but his in-person personality is very open to all the ideas you bring to him. If you say, I think there's a problem with your theory, he's open to listen to everything you have to say on that. So it was more like humility. Now, that was one thing I learned from him. Humility and persistence.
I have a question about your process with doing greenfield research. So you're talking about, hey, I need to come up with, research into AutoML solutions for, minimizing loss and determining where to route a particular, output from one thing to talk in a multimodal system of agents. When you're doing that research and you come up with your ideas, you mentioned humility in that process. Knowing that we all have bias about where we're going and the almost infinite possibilities that exist when doing independent original research, what's your process of internal checks and balances of sort of self-doubting or making sure that you need to provide evidence to yourself to convince you that you're moving down the right path to make those incremental improvements?
So I would say there were two things which I was pretty much insane for the first 1 year, which is I cried every single morning. I didn't get out of bed until 3 p.m. because I had this constant imposter syndrome. And I was like, I just want somebody to handhold me right now. And that wasn't really happening. But when it comes to eventually, I think after a point, once you realize you're pretty much by yourself, there's nobody going to come rescue you or tell you what's right and wrong. Then you start to read a lot of work. And that was my process, which is when it comes to AutoML research, I'd read, I think, about 700 research papers within the period of 3 months. And I didn't say, okay, these are the papers which are written by so-and-so lab, so they should be good. I just read very, very comprehensively. And I think there were 2 people who were my guides when it comes to selecting good research as well. So even before I started working with Julia, for about 2 years before that, I had a friend, Miles Prentice, who is now the policy manager at OpenAI. He was doing his PhD at Oxford. So he would teach me how to select the right papers and how to read a lot of papers very quickly. And the other person is David Ha. So I probably consider them more like mentors when it comes to that. So if I got lost with a particular research direction, most of the times I would go for advice to somebody who has already been through the process, or has already done all of that sort of before. All of them were pretty much as confused as I was about what's going to be the next big thing, what's the right research direction. So after a point, you realize nobody knows anything. People just have their own bias. Like you said, people have their own bias of what would be the right approach to solving a particular problem, and they just go ahead with that approach. The the only thing I did differently was, instead of sticking with one, which is instead of saying, let's work in Bayesian optimization, or let's work in reinforcement learning, or let's work in with biological algorithms, which is the genetic algorithms. I was more like, let me think about what are the problems and challenges with each of these approaches. So instead of saying, this is better than that, I started looking at them from like that external angle, which is, I may not be able to make great research in each of these things, and maybe I would end up picking something bad. But what's the common constant problem and challenge to each of these problems? So that was the work which I did, which is working on the problems and challenges in AutoML through all the techniques, all the learning techniques that there are.
Whoa. Okay. So the process was massive lit review of 700 papers. Then instead of reading what the papers were good at, almost, you looked at what the papers were all struggling with, and then found the core tenets, and then decided to research that.
Yes, and I also participated in on the practice side, which is most of the learning you can do is very much theoretical. But again, and there were AutoML competitions going on at New York IPS back then. So I started participating in those competitions yearly. I didn't win a prize because most of the people who were winning were more like people who were doing very excessive hyperparameter optimization, at least at that point. I didn't have those kind of resources because we were more like a theoretical lab. We didn't have the computational support, especially at our lab. So for me, it was more like, let's just practice, let's get the foundations right. For people who are winning, let me see what are their approaches as well, and go about in that direction, instead of, picking one and trying to put all my resources into optimizing for like a 0.2% gain at something else.
But the foundation that you built in your mental model of how to approach something like that, I think it's pretty unique. I haven't talked to a lot of people that use that, like that rigor associated with the scientific method of evaluating the results of other people's work and also of their own. And it probably gives you this really comprehensive understanding of how to provide recommendations to others who are trying to employ these things. How do you have that conversation when you were doing consulting, and you're currently doing consulting, when you talk to somebody like a customer of yours who is dead set on, this is what we have to use because this won some prize, or I read this one paper and this is like the hot thing right now? Do you actually sort of steer people to that success that you found in doing your research?
So most of the times it depends what kind of organization that is. I've done consulting for small startups where I'm directly working with the founder. They come from like an ML background itself. And I've worked with very big companies, which is companies that have about 800 employees and as such, which is the trading firms. So one of the things which I do, especially with founders, is I try not to say, this isn't going to work. I try to ask them, what their goals are, which is when it comes to any model, the first thing I do is to try break the problem into SLAs, SLOs, and KPIs. Once we know, okay, these are the SLOs that we want to define, which could be on every single parameter itself. So for large language models as well, you define your particular SLOs. I would say, the SLOs would be the latency. It could be the throughput as well. It could be the error rate. It could be the robustness. It could be consistency. It could be response time. It could be scalability, the capacity planning, or the data freshness, or the customer satisfaction compliance. So what I do is, for each of these things, I try to ask them what their SLOs are. So for example, when it comes to data freshness, asking, how often does your dashboard data get refreshed, or how often should it be? And then I try to sort of reverse engineer the problem, which is, if those are the SLOs and KPIs you have, is that the best model now? Are you still optimistic that this model can sort of achieve what you're looking for? And that's more so the way I think about system design as well as pipeline design, because it's not just the model itself. It's a very intricate solution that needs to be put in place. I don't focus that much on XYZ model is good or bad. I think you can optimize every single model if you really understand it well.
Got it. Yeah, that's very similar to how we do stuff in the field with Databricks. We look to basically define success, and that can take a variety of different forms. SLOs, SLAs, KPIs. They're an amazing start, but also what are your thoughts on sort of like the fuzzy, did this feel right definition of success? Like, are people happy? Does that matter, or is it all about meeting hard measurable criteria, in your opinion?
It depends, which is when it comes to bigger companies, a lot of stuff works by intuition because, again, they have years of experience in the domain, which I don't. I may say, this is what the error rate should be like, or this is what the perceived latency would be good. They may have a very different experience. They have that understanding of their audience and their customers that I don't have. So a lot of times, especially when it comes to that, we work collaboratively, and I don't try to stick by a measure. We do very intensive A/B testing with both the solutions, which is, at least when somebody comes to me and starts saying, this is what I think is right, I'm never the kind of person who will be like, this is wrong. I'll be the kind of person, I'll be like, okay, this is fantastic. Are you okay with testing one more thing as well? If it's not that much of a trouble, I think we can test this for this reason. These are the pros and cons. So I get them to buy into the pros and cons of my approach. We test both the things, and then whichever they select. I'm not that attached to the outcome, which is who has the last say in terms of things.
Got it. That makes sense. Ben, did you cater to the emotional needs of customers ever, or was it always come in and say the facts, leave?
Oh, it was always whatever, not specifically the emotion. I tried to avoid that as much as possible and get them to adopt evidence-based, results, because that's what I had done in previous jobs that I had. I was like, I don't care who builds this or who comes up with the idea. We're all one big team here. Like, even if you're working with an external company, when you're doing that work with them, you're effectively part of their team. You want them to be successful. So sometimes I found that I had to sort of fight against that, where it was more of a sort of who's the chieftain in the tribe who really wants their idea to be adopted, and get that person over to the side of, hey, we're all working on this together. Let's just let the data make the decision for us. You're looking to amplify click-through rate for this recommender system. Let's test it, but when we're doing the evaluation, let's avoid all of these pitfalls of cherry picking. So here's how we're going to design our experiment such that we're going to collect very high quality data and then use the appropriate statistical methods to evaluate this based on, temporal effects and cohorts of humans that are interacting with this. And I spent more of my time when doing like project work historically, way more time, usually 4 to 10x the amount of time designing an experiment and setting that up than I did on building models and pipelines and stuff. Because model stuff is generally somewhat easy. Tuning them is generally somewhat easy. But setting up, like designing appropriate experiment is just a lot of brute force work.
I think a lot of that comes with experience as well. So for me, like, I started my master's when I was 19 years old. So I finished when I was 20. So in my head, I was always, I didn't start out as this kind of person. I was the kind of person who would challenge the CEOs directly and always be like, I'm ready to fight, and I'll call people stupid. Your feelings are not my problem. So so when I went into like the workplace, that was my attitude. But I think it took me about 2-3 years to learn that that's not the right kind of attitude as well. And there's another way. Especially when like I was in school, my HOD told me one of the things you lack is diplomacy. And I was like, I'm going to learn how to be diplomatic as a person. And I always had this negative perception of diplomacy, which is it's basically people pleasing. But then I just learned. I think at one point I had this realization, which is you have data and you have information. The big difference is data is something which is raw. Information is basically something which is ready to be perceived by people. So there's a different, you have an understanding of the state of the other person as well. And what I stopped doing was giving people data. Now I think more in like the terms of information when I'm communicating with a team. It doesn't have to be just data. It has to be information itself. But that certainly came with making some mistakes in like my early career.
Have you ever seen, I can say I have seen, a born witness to this, where an effective person who understands how to do that data to information conversion, if they're significantly talented in mathematics and statistics, chooses to craft the narrative to the way they want to see it? And then have you ever caught somebody doing that and been like, please show me your work?
Yeah, there's a professor at USC. I'm not going to name names, but he's one of the professors in computer science department. He basically created research. He published a paper that got accepted as well. But what he did was selective data. So he basically rejected all the outliers that they were seeing to get the kind of map or the graph that he wanted to. And a lot of his research was essentially wrong, which is he perceived correlation as causation. And I was like, you're dumb. I didn't say it, but in my head, I was like, you're dumb. But I mean, he's not essentially dumb. He knows what he's doing. It gets him grants and all of that stuff. So yes, I have. People do manipulate data every now and then. They try to leave certain data points when it suits them, but I don't think that's. I think that's one of the beauties of large language models, I would say, which is with conventional machine learning models. One of the basic jobs that we were doing to make the model work really well was reduce all the missing data and outliers as much as possible. And now with large language models, we are at that point where we want the outliers. They make the model quality better. So I have that sort of mental association with fantastic. That would work well for you till, I don't know, like 2019. What will happen in 2050 when we have more advanced machine learning models? They would need those outliers to make fantastic performance. So, I mean, keep your tricks, but they will get outdated very soon.
Oh man! Wait, did you confront this unnamed professor, or what happened, or were you just like, he's dumb and didn't say anything?
No, I was mature by then to not pick fights for no reason.
Didn't like run up to him and smack him in the face, say you did this wrong. Okay.
No, I just pointed out, which is I think you missed a couple of things. And I pointed out the factual inaccuracies, but I didn't say anything about his personality or why he chose to do something. I was like, I think you missed this point. Obviously, it was put in a way that was way more polite. And the conversation in my head was not that polite.
I mean, that's a benefit you get from, I think, academic peer review with ideas, but something that, depending on what the politics are at a particular organization in industry, there is no peer review, or peer review is stifled intentionally, and dissenting voices are kind of, pushed to the side when somebody has this grand idea. Do you ever see that in consulting work, or have you seen it in consulting work where you're like, okay, I'm walking into a political minefield right now, and I need to navigate this in such a way that we are making the same sort of evaluations of an idea that we would, or the results of the test of an idea that we would in academia?
So somebody having the say in the final opinion, or somebody just suppressing everybody else's opinion? Is that what you're asking?
Usually the person, the things that I've seen are the person coming up with that idea, or they're going off on their own, building something to prove to everybody that their idea or their approach is better than anything else, and then not showing their source code.
So especially in consulting, I don't think I've seen people not showing me the code. Most of the reason is, I think, because I'm doing consulting, and they're hiring me and paying me for a certain reason. So I'm there to help in the first place. So no, but one thing I've seen is people building their own stuff. And with that, I try to be more open-minded now. I would say in the past 6 years that has been a change, which is if somebody's taking the initiative to build something, even if it's bad, then I don't go in and say, okay, I think this is stupid. I'm more like, okay, I think fantastic, you've done this. Now let's see how can we improvise over top of this thing itself. So I steer them back to my thing by saying, let's improvise this. So if they've implemented, let's say, one kind of evaluation system, then I'll be like, what's the result of this? Can we try this? Can we improve this by any chance? And let them brainstorm. So that's something which I think Robert Greene says in his books a lot, which is let people think it's their idea and not yours, and you'll have it very easy in the workplace.
Could not agree more. We've done an entire podcast episode about that, actually.
I was about to say, yeah. Sounds kind of familiar. Because just the recap of mine, Ben's conclusion at least, was if someone thinks it's their own idea, they'll be a lot more emotionally attached to it, and therefore they'll champion that idea a lot more than if you say this is the correct method.
But the thing I hate is I don't hate people who take initiative and build their own thing. I hate the kind of people who just want to have that mental masturbation in the room and say why something isn't going to work. Those are the people I find are the barriers to success as compared to people who go on a tangent entirely and work on their own solution. So execution is something I appreciate, even if it's not perfect, even if it's bad execution, I'll appreciate it.
So to clarify, if someone just is a naysayer that's like putting down people's ideas without an alternative, that's what you don't like?
No, even if there's an alternative, but if you're not executing, if you're just talking about things, then that's something which I hate. Not everybody is an executor. There are a lot of people who just likes talking about things. They are theoretically very sound. They know how everything works, but when it comes to implementation, they can't do crap. So those are the people I find particularly annoying. And so them over a person who will do their own thing and is super stubborn, I'll go with a super stubborn person who will implement something. And then because I know I can work with that person very easily, I can say, let's improvise this, let's implement this. I've written this code, can we integrate this? I'll give you my code, can you sort of implement this in yours? And so I find them easy to steer as compared to the people who are like, I'm not going to do anything, but I'll tell everybody what to do.
The idea people, they're probably, I share that sentiment with you. Those were always the most frustrating humans to interact with in a technical environment, because when pressed to like, okay, you said this idea is terrible, you have this better way of doing it, show me on Friday, you got 4 days. Like, it doesn't have to be perfect production code, just get something. You don't even have to test, just I want to see it execute. And they always have excuses or just fight against that. And then sometimes having that conversation with them one-on-one, be like, can you actually implement what you said is a better idea? And a lot of times those better ideas that you hear are not even possible outside of theory. It's like, yeah, that algorithm that you're talking about, this is how long it would take by my estimation. Let's write a simple test to see, you think this means of optimizing is substandard, but you have this great idea. What's the operational complexity? Like the big O notation for what you just explained. And then you walk through on a whiteboard with them. You're like, this is, of such significant complexity, O2 to the N or something. And N at the minimum value of that is in the tens of thousands for this iteration. this isn't going to complete on, silicon-based architecture anytime soon. So let's just go with this other one that works.
Yeah, I think that's the thing with the idea people, which is they always have better ideas, but they're better ideas on paper. They're not essentially better ideas when it comes to execution. So it's one of those frustrations that I've shared, especially with people, especially while working with junior software engineers, which is one of the big conversations among junior software engineers is let's use this language, let's use this framework, and which the company isn't using. And 99% of my effort, especially working with those people, is usually trying to get them to use the ecosystem or the tools and the frameworks that we already have, because there's a very good chance and I've seen it with them, which is I've made a couple of them fail as well. I've not made them fail, but they didn't consider, which is it's not scalable enough. There's not libraries, there are not enough libraries for the kind of application that we're looking at. There will be a point where they'll hit a hard stop and they're not willing to go build in open source to support that kind of the missing piece or the missing dependencies, as compared to what the company is already using. So those were sometimes frustrating kind of people, but I think that happens especially when you work with juniors in any sort of work, because they want to experiment things, they want to learn more, and I think a lot of learning happens when you start optimizing instead of experimenting with a lot of different things. Or at least that has been my experience, which is the most learning I've done is when I try to optimize a system that has already been built by somebody else.
Yeah, that's a really, really interesting point. You already have a logical framework and guidelines that you must navigate. So I always found that constrained problems are actually a lot more interesting, a lot more fun. And because it's not greenfield, I can't just go do X, Y, Z. I actually have to think critically, and it's sort of by definition more challenging. But also because it's within a logical framework, there's something that's existing and that's already meeting a use case, so there will be value from the outset. So if you can improve by 10%, whatever metric of interest it is, latency, accuracy, satisfaction, you can really provide a lot of results that are valuable.
Also, another anecdote of something very similar was one of the consulting works I was doing. We were working with a company, and they said, "Why don't you implement simple, a bit more complex deep learning models for the kind of application that we have?" Because again, they wanted to make the presentation to the VCs and as such. And the existing models that they were using for another application, but in the very same domain, were working very well, but they were simple statistical machine learning models, so like GPM kind of models and such. So that's one conversation I've had to have with the CTO of the company. I was like, I'm okay with implementing a more complex model, but you have to know that I'm not guaranteeing that it will have better performance. What do you exactly need? So let's think about your KPIs first. Do you want to be able to catch errors by so and so rate? If so, I can take the existing algorithm that you've applied for a different use case in the same domain. I'll implement that same thing and improve the performance on that one. And that's essentially what we did. So I got that pushback about 2-3 times in that process, which is every single time a board meeting was coming up, they wanted to show something which was way cooler. And 99% of the times, the cooler things aren't essentially what will get you closer to solving the actual problem. Or the business problem itself, because some algorithms do work really well with a particular kind of data. So let's say if you have geopositional data or if you have time series data, then any of the gradient boosting ensemble methods will work very well with those kind of models itself, as compared to like, let's try to implement a transformer model onto that one. It's probably not the greatest idea.
Yeah, your story makes me viscerally frustrated. Why do people think that what is cool? Can you define to me what other people think is cool? And like, why is not the most optimal solution the coolest solution? for both of you, like genuinely, what in human nature makes a transformer cooler than linear regression?
Because it's new, I think. I think humans are fascinated by shiny new objects, whether that be an idea or a new technology or a place that we haven't gone before as a species. People get really excited about that because by nature, evolutionarily, we are explorers. We are always curious about the things that we don't know about. And sometimes not sometimes, many times I've seen that exact scenario play out with working with a customer. I remember having a conversation for too many hours with a team of data scientists that were all, I think the most senior person on the team was 18 months out of undergrad. And they're just like, we really want to get, we have this time series, this forecasting model that's supposed to, estimate how much we're going to sell of all these different products. I'm like, cool, awesome. Like, how does it work? And they're like, well, it's not totally optimal for these particular types of products in these particular regions. I'm like, okay, are you like missing data? You don't have like no sales for a couple of weeks or something? And they're like, yeah, that's exactly it. I'm like, okay, tell me what what your proposal is. Like, why am I talking to you, basically? And they're like, well, we need a deep learning expert to build like a single meta model that does all of it. And I'm like, I'm not that person. Like I can build deep learning models, but I don't know if I can like replace what you have right now with a single model. I don't know if you have enough data, and I don't know what the appropriate architecture might be for constructing that with what you want, PyTorch. I'll go and read some papers for you though, and I'll try to figure some stuff out. But like, let's think about how we can solve that problem that you have of, hey, these certain markets and these products, I don't have enough data to, estimate what that forecast should be. Can we just think about how we're assigning these hierarchies of where these products are in what markets? Do we need to have it as each individual SKU at each store? Is that effective? Can we look at geographically? There's got to be a distribution warehouse that provides these materials to these stores. Can we build a model for the sparse data that goes at that distribution center? And then the distribution center has humans that are smart and they can figure out where to ship stuff when they need it. But you need to place orders to handle that distribution center. And there were a couple of people in the room that were like, we never thought about that. Let's try that. And we were done with the engagement within 4 days because all we did was just make some very simple configuration changes in the code, and it worked. They were bummed out that we couldn't use a torch model to do it all. So I gave them a little hackathon project that I worked on them with, where they wanted to learn torch. And that was really their excuse. So we did some image classification and object detection just for fun with like data that they had. They had warehouse cameras and video feeds. So like, let's detect if we can see if there's a risky operator moving forklifts around, and in order to be able to detect when an accident may occur. And they built like this cool prototype, shared it to management, and they're like, we need to actually make a project out of this for safety. And I'm like, cool. That's an appropriate use of that model or of that framework.
Yeah, I think I agree, which is there are two sides of it. One is the side that Ben mentioned, which is there's that curiosity to learn for whatever reason, because they want to build some sort of monopoly in the market, which is we've applied an algorithm which none of the competitors has already applied, so we're ahead of the curve. The second part is the FOMO side of things as well, which is there's only so much stability that we have in the workplaces today. It's not unusual for companies to go down or the careers to stagnate as a place, and you don't want to lack the skills as well. So I think a lot of people come from that FOMO perspective as well, which is I want to, if everybody else is using transformer models. I want to implement transformer models as well, because applying to a newer place or newer company, which is now doing well, they might be working on transformers. So I need to have some sort of work experience in my current workplace that already implements that. So from a career standpoint, and I mean, even when it comes to talking to VCs, it's the same thing, which is people who pay you money. Most of the people are not paying you money to keep doing boring things. 99% of the times you have to innovate in some way or the other. If you can't really innovate in terms of 99% people cannot really innovate in terms of customer acquisition itself. So what they try to do is to innovate in terms of tech instead. And I think that's probably one change which is happening. I think with the whole people who are building up wrappers right now, which is a lot of people have made a lot of money for particularly that reason, which is you don't always need to innovate the technology. You can use the endpoints as is. Understanding customer acquisition is usually the hardest part of the problem, but it's also the more frustrating part of the problem, and it's not the sexy part of the problem to a lot of people as well.
What are some problems that you're currently excited about?
So a couple of them. One is, I would say, recommender systems, because I've worked extensively in like the e-commerce space and mostly in the whole in that domain where we were working on recommendation systems of one way or the other. So those are the ones which I'm personally excited about, because there's so much business, there are so many retail businesses, and there are so many e-commerce businesses that are still struggling with that, where people are not able to search for the right thing, or there's a very minimal comparison that people are able to do right now on their websites. Even when you take Amazon as well, which is, even though they've gotten good at recommending people more products, they can get better as well. And that's one place where most of the Shopify-based companies are sort of missing out, which is if they're able to recommend things better, then they are able to sell more. So I'm a capitalist when it comes to that. People should sell more. And the second is, I would say probably a lot more people are excited about autonomous agents. I'm not as much, but I'm more interested in audio speech synthesis, because again, there's very high latency with Amazon, Alexa, and all of those systems. I've been working with so much real-time data. I think that's one place which has been lacking attention, which is there's not a lot of systems, home devices and home systems in this space, particularly because of that reason. One is the size of the data, and the time taken to basically do inferencing on the models itself can be very high.
Got it. Going one level deeper, why are those the areas of interest? Did you do your 700 paper lit review and think these are the core issues, or is it just cool to you?
So I worked in audio speech synthesis in 2021, 2022, which is when we were building up. So at one of the companies, we were building up the TikTok kind of application. We didn't get funded eventually. We ran out of money. But the other application that we were building was a voice filtering system. So basically, like you have, I don't know if you've used this app called Voice Mod, which allows you to apply filters and sound like a child or sound like an old man or something. So what that allows you to do is to mimic certain voices, or to be able to change your voice into something completely different. So for me, I was like, let's try to work on this. We very quickly ended up hitting limits when it comes to hardware itself. So in Windows systems, their drivers are pre-locked in. When it comes to Mac systems as well, the drivers are not as open. There's a single library, I think it's called Black Magic or something like that, which allows you to be able to work on something like that. But Microsoft isn't working on improving that side of things either on like the entire Windows systems. And one of the core reasons for working on that was there are so many people who are still dealing with I don't understand your accent. So for me, it was more like one from an educational point of view, and second from a hiring point of view as well, which is we can anonymize people by anonymizing their voices and anonymizing their accents as well. So we can reduce some bias. Same when it comes to YouTube as well, when it comes to creators who think one of the big limitations for them is basically their voice. We can sort of change that entirely. When it comes to movies as well, you do the same thing very quickly, which is you can very quickly give people an accent wherever you want, using their original voice without taking basically how they actually sound like.
Got it. That's super cool. Yeah, and there's obviously a bunch of nefarious applications of that, but there's also some really good low latency, like Alexa's, as you mentioned. Like that's a classic example that would improve many lives. And are you planning?
Labs is working on it, but there are very few companies there. So there's probably 4 or 5 companies that I know in the space that are working on very specifically audio speed synthesis. So I think it has so much potential, especially like when you start implementing Alexa systems. So thinking every single device in your house is going to be voice enabled in the future, which is your beds will be voice enabled, your tables will be voice enabled, your bulbs and everything will be voice enabled. The big barrier would be those technologies sort of understanding people's accents and people's voice and how they create their sentences or all of those things. So right now, I think what Google has done is they've really provided a lot of data to Google OK or whatever their thing is to be able to understand how people say certain things. But I don't think it's as close to somebody speaking like a local. So for example, if my mom tried to speak to it, probably she would have problems getting the exact search that she wants to. And that, for me, is like one very important point of being able to search in the future, which is we're not going to type as much, at least for very simple things.
Do you think we're going to need to create Gen AI to solve, because all these problems are tangential, like self-driving cars, speech, audio. Is there going to be one model that just bashes a bunch of these problems and checks off all the boxes, or is there going to be small independent models that does each one individually?
So I would say it depends on the scale of the application itself, which is when it comes to companies like Google implementing such a solution, instead of having one single model, they would have multiple models, which is it comes down to compliance side of things and the optimization side of things. But if a company has, let's say, about 1,000 users itself for the application, they don't probably need that level of optimization. Or if they're simply focusing on a single geography, they might have just one model. So it comes down to like, what is the serving scale and what is the diversity of that serving scale itself?
Yeah, that makes sense. It's like the general purpose GPT versus a fine-tuned Llama 3, for instance. Yeah. Okay, cool. And then another question to that end, how are you spending your time? Are you working on these speech recognition models? I heard you're writing a book. Is that going well?
So we're working on the early release of the book. I've already submitted 6 draft chapters. We have 10 chapters in the book, but I write about 30 drafts before I actually finish a chapter and say it's done. So it will be by, I think, end of this year or early next year by when the book would come out. But the second chapter is ready for like early release. So that would come out probably next month or so. So yes, that's what's happening. The consulting work is still happening, which is I've moving away a little bit from like spending so much time on development, which is the engineering side of things for them, and more so focusing on the training side of things, which is right now, last month itself, I was training a team, which is a couple of software engineers, IT people, and everybody on how to implement large language models safely, helping them build solutions. So like, instead of hiring a Gen AI team from outside and instead of hiring random people from Twitter, because everybody sounds like the smartest person on Twitter, but hire them and they don't know how to do anything. So a much better solution is hiring people internally. And that's what a lot of companies are doing right now, which is taking people from different teams and combining them together and training them to be able to build solutions, because they already understand the company and the problems inside out, and they have very realistic understanding of what the KPIs would be and when would implementing something make a difference and when it doesn't. So that's been one of the focuses. And then working on my own startup as well, which is we're working on a product to more so like build a second brain, which is more like a dream project. I've wanted to do that since I was probably like 19, 20 years old, because I've got ADHD. I can't remember all of the things. I don't have the best executive function, which is I have to learn. I do sort of really, really teach myself on how to not get overwhelmed. Also, how to manage multiple things as well. Right now, basically, I'm the kind of person who cannot do 500 different things at the same time. There are a lot of people who can be highly stimulated at all times. I'm the kind of person, if I start coding, I will keep on coding for 10 hours. And if you talk to me in the middle of that, I'm not the most pleasant person to have a conversation with. So I don't do context switching that well. So that's pretty much my my week, that's pretty much what is happening, which is the writing. The training, I've already created a lot of training material. I'm planning to put it on like some sort of website, Coursera or Maven or something like that. O'Reilly is already, I'm having a conversation with them. It's in the early stages. I'm talking to Manning as well. They want to implement some of the content as well. And the third thing, which is the productive, which is where I'm putting in all my engineering juices instead.
Do you sleep?
Yes, but I have trouble sleeping, which is I can sleep for 5 hours, but I don't think I can always sleep more than that. Once a week, I'll sleep like 10, 11 hours.
Wow, it sounds kind of sporadic. And It works for you?
It does, which is, I don't know what I'll do. If I sleep too much, I get bored. I keep waking up.
Like, I could be writing code right now. Might as well wake up and do that.
Yeah, I mean, I think it depends on how much work are you required to do, as well, and how many dreams do you have, which is like every single time I'm going to sleep, in my head, I'm thinking of how many problems can I solve if I was coding instead, if I was building up the solutions instead. So, for example, every single time I get irritated with humans, and I do get irritated with people a lot, I am the kind of person who's like, I'll replace you with a machine. I don't say you're a bad person. I say, I'll replace you with a machine in my head. So the same conversation goes. If I'm irritated with my parents over something, which is they probably didn't ask me what I'm going to eat or something else like that, I'll be like, one day I'll build a machine that will ask me what to eat and bring me the same food. So there's way too many problems to be solved.
So that's why you started this company, to replace your parents?
No, not to replace my parents, but to replace people, replace the dependency on people. I think I'm one of those hyper independent people that doesn't really like to rely that much on others. I can ask others for help, but I don't like that when I feel helpless, which is I really depend on you for something else. So I built this company to sort of remove that reliance on humans entirely. Obviously, it will not be removed. The company needs people. The systems cannot run themselves. They need to be monitored. There will be people working. But again, I think as long as we're working on that solution, which is making people more and more happy, and the technology being there for the sake of human beings instead of something that we have to learn because of our careers, I think that's one of the best places to be.
Seems to be a common theme in a lot of builders that we've talked to on these interviews, is that is the sort of the underlying foundation of most people's motivation who are trying to build stuff with AI, like systems or platforms or frameworks for people, is that effectively what you said. It's like giving people agency again. So if you are reliant on another person for things that could technically be automated, we have the technology to do that. I really like that idea that you have about like that second brain of like, I need improved short-term and long-term memory storage and a system that I can interact with for that.
One of the things that we're implementing is very similar to how our conscious and unconscious brains work, which is we're constantly storing all the information, but we're not accessing all the information at every single point in time. So one of the things that LLM systems are really bad at doing is they don't have that segregation of what was something which was 2 years ago, and this is no longer relevant. This doesn't need to be retrieved as much. So having that understanding of what are the most relevant and recent things that might be impacting your decisions, or what would be the things that you're looking for, so as to be able to help people, what are they trying to do next.
It's almost like implementing something like an RFM framework on terms of contextual access of memory could be beneficial for something like that. Like, how recent was it accessed? How many times was it accessed? And what was the qualitative impact associated with accessing that information? Like, how relevant was it? And then almost like scoring, like, should I look for something?
I would say, though, the downside of that is if you implement basically weight associated stuff with it, then the problem is it converges too quickly as compared to looking at the entire hyperparameter space. When you're just missing out on so much information, that what's the point of training the model on the massive data? So that's one of the reasons we're implementing knowledge graphs, so we can learn the hierarchies of certain information, how that is basically stored within the model itself.
Do you mind giving us a 60-second overview of the architecture and the secret sauce that can be publicly shared? If that's possible.
Probably in a few months from now, once the implementation is out. It may be too early for that. But not from like, okay, it's something to be hidden, but we need to know it works well. So we've not done evaluations entirely on that system yet.
Got it. I'm curious about what the plans for evaluation of something like that would be when you're accessing something in that knowledge graph about, like, okay, what am I going to retrieve and how is that going to change over time? Would you use something similar to like almost like an evolutionary algorithm to determine where you're going to go for modifying or maintaining that system?
So I would say evolutionary algorithms are really well when you're looking at a problem that needs creative solutions, which is, now how can I look for something new? So any sort of open world games and all of those kind of problems are where evolutionary algorithms work well. The way we're doing evaluations for this is particularly, we've done two parts, which is, one is we've focused a lot on the retrieval itself. And when it comes to retrieval, although there are a few parameters of retrieval, for example, like there's recall, there's MRR, there's context recall as well, and there's context relevance you're looking at. What we're doing is we're also integrating some sort of KPIs with that are associated with human input as well, which is how much of that is being used. How often is the person querying again and again for the similar kind of information as well? Are they digging deep into this thing, or are they trying to reiterate the same question itself? If they're asking the same question again, then probably we're not giving them the kind of response that we should have generated in the first place. So what I've done is basically created a sort of system to be able to rank the responses based on how people are interacting with the model itself, and the kind of consequent conversation that is happening within that context itself.
So you could effectively train a system or a framework that can do this such that it's optimized for human retention of information at the appropriate level of response.
Yeah.
So if you're like, hey, we're giving too much information in this response, because it has all of this context, or it's too complex of a topic to be at the level that we're presenting it. So somebody has to search it 7 or 8 times over a 2-week period to really grok what's going on.
Exactly. So
also,
that's,
if it's too high level, people will like start digging even further into it. You're like, okay, maybe we made this too simple.
that's essentially what we're doing, which is we're building a ranking system based on that very specific thing itself, which is based on every single conversation. Can we rank how much information was actually used and how much was actually being asked for once again? So let's say if the person was only looking for like certain names, but we're giving entire definitions, and then we're giving a table or something which is like extra context around the same thing, which is not really useful. So for example, if you're looking at what are the competitors for XYZ or what are the alternatives for XYZ framework, instead of giving the definitions or the deep dives of how every framework works, just giving it the simple names and letting people generate the next question and seeing if that question is relevant to like the one of the names that we already presented in like the earlier conversation itself.
How do you feel about bootstrapping systems like that? Like there'd be an initialization of the state for a particular user, and then an ID would be assigned to a human that's interfacing with that system. Would that adapt over time? And do you think products like that are viable for, there's some amount of that with OpenAI where it's like, okay, the session ID associated with it that now spans across multiple sessions, it seems like it's kind of customized. Like my wife and I have tested stuff of like, I'm going to ask a bunch of questions and then you're going to ask the same thing, but in different ways, and see, does it diverge at some point? And to a certain degree, yeah. But how do you feel about hyper personalization of stuff like that, where it's like everything that you ask it, the system starts to build adaptable responses to that individual person that are actually relevant?
How do I feel about that? I think that would be ideal in the long run. In the small run, which is they're getting the information that they want to, it would be really hard. And that's one of the reasons why I said evolutionary algorithms are not one of the greatest choices, especially in this kind of scenario, because 99% of the times, every single time you're generating a different response for different people as well, then it's very hard to be able to test what remains accurate as well.
Right.
So there divergence between, you have to always maintain the level of skewness between responses, as long as that skewness doesn't really leave a certain threshold that you're good.
You're optimizing messages for human understanding. How do you evaluate that?
Messages for human understanding. So what we're talking about is basically like the generation side of things, right?
Yeah, like you were talking about how much of a information in a piece of text is actually used and how much is sort of discarded by the human brain. How do you evaluate that?
So as of now, what we've really implemented is basically like the query level understanding of how relevant is the query from the last query itself. And how many words are sort of reused and how much context from the previous conversation is reused once again. So that's on the basis of that, we're sort of building up a threshold system. But again, we don't have, and that's one of the reasons why I said, maybe not the best time, because as of now, all of the optimization that we've done is just for one person, which is for myself. We've not really put it at scale where we're testing this system for like 100 users and then seeing what really happens. And that's where I can say for sure, I think we've sort of established the relevance of this thing, and we know for sure that this system actually works.
Crystal clear. Okay, cool. Thank you for letting us dive a little deeper. Excited to see maybe some blog posts. Would they come out in a few months?
There would be blog posts very regularly, one a week. I've put some down into my drafts and stuff, but again, I've not published them, but I was planning on doing it more regularly. Now the book is coming out, I need to generate interest. So it's primarily for marketing reason, but one of the things that's already out is a report I put out on what is LLMOps. So that is on the O'Reilly website. I'll give you like a link on the email after this itself. So what that does is it defines what large language model operations is. Why do we need that? And the 5 or 6 applications that we were going to talk about that we didn't get a chance to talk about that much. And then what are the big problems when it comes to operationalizing large language model? How does that sort of divert from MLOps or the basic MLOps that we were doing for like the past few years? So there's not massive focus on like the tools and frameworks, but there's a big focus on what are the things that we need to measure when it comes to the life cycle as well. What are the things that can essentially go wrong?
Crystal clear. Okay, cool. Well, we are over time per usual. And we also didn't even talk about the stuff that we were talking about before kicking off recording. Maybe there's another episode per usual. Maybe there's another episode in store. But I'll quickly summarize some of the cool points that I heard on this episode. So first, when you're breaking down problems, try to break them down into SLOs, SLAs, and KPIs. Metrics are super important for evaluating success. And also from a contractual perspective, you can point to them and say, hey, we did the job or we didn't. When communicating, try to convert raw data into context-aware information. And the context not only includes the person that's receiving it, but also context about the problem itself. You learn more when optimizing than just doing greenfield prototyping. And evolutionary algorithms work well with outliers, for instance, creative problem solving for your digital brain. So Abi, if people want to learn more about you, your work, your book, where should they go?
The best place would be my website or LinkedIn, or I'm not super active on Twitter these days, but again, there's so much content I've put out on Twitter, which is what I do on Twitter is I'll leave threads. Anytime I'm reviewing papers, I review papers, which is every couple of months I go in and say, these are the best papers you can read in the space. And these are the summaries of each of these ones. So if people are looking for research stuff, go to my Twitter. If people are looking for more implementation, operational engineering stuff, go to my LinkedIn. If you want deep dives into something, then go to my website where I have a blog. So that has really good, very deep blogs with a lot of mathematical stuff that I can't really get to put. Like latex equations won't really work well on Twitter or LinkedIn.
Right. Yeah. More short form little like math is cool statements, not a LaTeX. Yeah.
Yeah.
Okay, cool. Well, this was a lot of fun. Thank you for joining. Until next time, it's been Michael Berk and my co-host,
Ben Wilson.
And have a good day, everyone.
We'll catch you next time.